Ionization energy, A-level chemistry. When we talk about ionization energy, we're talking about removing of electrons. So the first ionization energy is defined as the energy needed to remove one electron from each atom in 1 mole of gaseous atoms to give 1 mole of gaseous 1 plus ions. So the correct definition has to be gaseous atoms and gaseous 1 plus ions, and both of these are 1 mole. For example, when we have sodium as a gas, when each atom of 1 mole of sodium loses 1 electron, that will give you 1 mole of gaseous sodium plus 1. And this is the ionization energy, the first ionization energy. If we are talking about first ionization energy and we said first, that means there are successive ionization energy. So for example, we can define the second ionization energy as the energy needed to remove 1 electron from each atom in 1 mole of gaseous 1 plus ions to give 1 mole of gaseous 2 plus ions. Again, we have sodium ion here plus 1 in the gas form as well. That will give you sodium 2 plus in the gas form plus the energy. And this is the second ionization energy for the sodium. So what are the factors that affect the ionization energy? You can predict the ionization energy, whether it's going to be higher or lower, if you compare the different atoms within or different elements within the same period or within the same group. So there are three factors that affect ionization energy. The first one is the nuclear charge. And the nuclear charge here means the number of protons inside the nucleus. So if there are more protons, that means there will be more positive charge and there will be stronger attraction between the outer shell electrons and the nucleus. So ionization energy will increase to the right of the same period. So this factor affects the atoms or affect the elements within the same period. This is why ionization energy increases to the right of the same period. The second factor is the distance from the nucleus. And the further away the outer shell electrons from the nucleus, there will be less attraction between these electrons or between the outer shell electrons and the nucleus. And you can see this effect across the same or along the same group. So ionization energy will decrease down the group because as you go down the group, there will be the outer shell electrons will be further away from the nucleus. So that will mean the ionization energy will decrease because the outer shell electrons will be less attracted to the nucleus. And finally, there is the shielding. And shielding means here the effect of the inner electrons and how they shield the outer shell electrons from the nucleus. So the higher the energy level, more electrons will be between the outer shell electrons and the nucleus because there are the inner electrons. The inner electrons will shield the outer shell electrons from the nucleus, and electrons will be less attracted to the nucleus. Again, for the same group, this affects the elements within the same group. So ionization energy will decrease as you go down the group because there will be more energy levels, there will be more inner electrons, so the outer shell electrons will be more shielded from the nucleus. Electronic shell structure and the successive ionization energy. This is the graph for the successive ionization energy of sodium. And we can look at this and we can look that within each shell, the successive ionization energy will increase. So this is, for example, the second shell for sodium. And as you can see, the successive ionization energy increases as we go up or as the ionization energy increase as we remove 1 electron each time. This is within the same shell. This is because electrons will be removed from an increasingly positively charged ion. Every time you remove 1 electron, the overall charge of the ion will increase, which means that there will be less repulsion between the electrons, and the outer shell electrons here, which are going to be removed, will be held more strongly by the nucleus. So you will need more energy to remove that electron. And then when you look between the shells, so this is the outer shell here for sodium, and the second ionization energy for sodium will be removing electron from a new shell. And also you can see this between the second and the ionization, the second shell and the first shell as well. So there will be always a jump between shells, as you can see. When electrons are removed from a new shell, there will be a big jump in the ionization energy, like this jump and like this one as well. This is because electrons are removed from a shell which is closer to the nucleus. And if the electrons are closer to the nucleus, that means they are held more strongly to the nucleus, and then we will need more energy to remove the electron. So what information can we make if we are provided with the successive ionization energy for any element? Again, let's have a look at the successive ionization energy for sodium. The first thing is that we can find out what group the element belongs to. This is when you look at how many electrons are removed from before the first jump. So here for sodium, for example, the first jump you can see it after removal of one electron, which means there is only one electron in the outermost shell for sodium. So we can make a conclusion now that sodium belongs to group 1. We can also predict the electronic structure for any elements, and this is when we look at the successive ionization energy and we start working from the right to the left. So now you need to count how many electrons are removed before each jump. So let's have a look at sodium. So there are 2 electrons removed first, and then we have the first jump here, which means the first energy level has 2 electrons. And then we have 8 electrons before the second jump. So the second shell has 8 electrons. And then finally, we only have 1 electron, which means the outer shell electron has 1 electron. So now we can predict the electronic structure for sodium as 281.